Hi friends, this is the lecture number 1. Today we will discuss on this question, that is Lagrange's method. Okay, so in the Lagrange's method, what they have given you, suppose someone has given you one such type of function. Function we are using the partial means this time you have such type of function where variable is more than 1. If you have any such type of function, f of x is equal to x square plus 2 or sin x or sin x e to power x, so you can see that there is only one variable, okay, but here more than one variable. If you have more than one variable, okay, then how to find the maxima and minima already we have discussed. Okay, you can go in the previous lecture. If you have a function and this function has more than one variable, then how to find the maxima and minima. If we have single variable, then how to find the maxima and minima, we have already discussed. Now here we are talking, suppose someone has given you one function f of xy is equal to xyz, and also he has given you the constant, means you have to find the maxima minima by the help of this constant. Okay, so this time you have one function and second is the constant, then how to find the maxima minima. So in this condition we will use Lagrange's method. Lagrange's method, so L, x, y, z, lambda. So there are total number of 4 variable. Lambda is the scalar, is equal to f of x, y, z. This he has given you, plus lambda. Lambda is the scalar value. G, x, y, z. This is this constant. Okay, this is this function, and this constant is this. Okay, you will put the whole both value will here, that is L. Okay, then after del L is equal to 0, means you have to differentiate this L with respect to x, y, z and lambda, then after it is equal to 0. This L you have to differentiate with respect to x, with respect to y, with respect to z, with respect to lambda, then equal to 0, then you will get something, then you will solve it, then you will get the solution. Okay, we will discuss in this question. Okay, so this time you have what they have given you, f of x, y is equal to x, y, z, and they have given you g of x, y, z is equal to, there are total number of 3 variable. If there are total number of more than 4 variable, suppose x, y, z, p, q, then you will write x, y, z, p, q. This time there are only 2 variable. Okay, so in 3 variable, so we are putting this x plus y plus z minus 1. Okay, so we this is the function they have given us, and this constant they have given us, we denoted by the help of g, and this we denoted by the help of function f. Okay, so now we will put both here, then we are putting here, then x plus y, L, x, y, z, lambda is equal to this function f, x, y plus lambda g, x, y, z. Okay, so this is equal to f, x, y is equal to x, y, z plus lambda, this x plus y plus z minus 1. Okay, now this is, now we will differentiate with respect to x, then del L upon del x is equal to this. If you will differentiate this with respect to x, then both will be constant. You will treat these are the constant, then you will get y, z. Differentiate with respect to x, this is the constant. Okay, then you this 0, 0, 0, but you will get lambda, plus lambda is equal to 0. After then 0, then again you will differentiate with respect to y, so both will be treated as constant. Differentiation of y is equal to 1, then you are getting xz, plus differentiate with respect to y, this time all are 0, only this one constant into this is equal to lambda is equal to 0. Again del L upon del z is equal to xy plus z, again you will get lambda is equal to 0. Differentiate with respect to lambda, this is 0, lambda, then this time the whole thing it will be constant, treated as constant. So x plus y plus z minus 1 is equal to 0. Okay. Now you have 4 equations. These 4 equations you have to solve. It means that you are getting lambda is equal to minus of yz, lambda is equal to minus of xz, lambda is equal to minus of xy. Okay, you are getting lambda is equal to minus of xy, lambda is equal to minus of xz, lambda is equal to minus of xy. And here you are getting x plus y plus z is equal to 1. So you have this equation. Okay, so now you have to solve it. Okay, you can see also that if you will cut, then you can see that y is equal to x. You can also cut this x, then you can see that z is equal to y. So by the help of this conclusion, this equation, we can get x is equal to y is equal to z. Okay. Okay, now put here, then you are getting x. Suppose y is equal to x is equal to y is equal to z, y is equal to x, z is equal to x, then x plus x is equal to 1, 3x is equal to 1. It implies that x is equal to 1 upon 3. Similarly, if x is equal to y is equal to z, it implies that x is equal to y is equal to z is equal to 1 upon 3. Okay, so you got x is equal to y is equal to z is equal to 1 upon 3. So it implies that the maximum value f of xy, they have given you x, y, z. Now put all the value here, then 1 upon 3 into 1 upon 3 into 1 upon 3, 1 upon 27. That is the maximum value. Okay, these are the points 1 upon 3, 1 upon 3, 1 upon 3. These are the points 1 upon 3, 1 upon 3, 1 upon 3. These are the maximum point and this is the maximum value. Okay, this is the way to find any question. Okay, now again we will solve another question. That another question will also, it will clear your doubts. I am erasing. Okay, this time they have given you this question. F of xy is equal to this, x square y square is equal to this. That is the constant. They can give you anything. So our equation is this: L, x, y, z and lambda. This time there is no z. Okay, I am just writing only x, y and lambda. Okay, so is equal to f of x, y plus lambda g of x, y. Because there are only two variables, so I am writing like this. Okay, so is equal to, this one is equal to 5x minus 3y plus lambda. This is equal to x square plus y square minus 1 3x 6. Okay, so now we will differentiate. Okay, we will differentiate with respect to x, y, z and lambda. Okay, so del L upon del x, if you will differentiate with respect to x, then this is 0, then you are getting 5. Okay, you are differentiating with respect to x, then this will be 0, then this is 2x, then plus 2 lambda x, okay, is equal to 0. This is the first equation. Again you will differentiate with respect to y, del L upon y is equal to this is 0, then after then you are getting minus 3 plus lambda differentiate with respect to y, then you are getting 2y lambda. Okay, this is equal to 0. Now differentiate with respect to lambda, then this is 0, but this is treated as constant. Del L upon del L is equal to 1, x square plus y square minus 1 3 6 is equal to 0. Now you have to solve it. By the help of this, you are getting lambda is equal to minus 5 upon 2x. Okay, again by the help of this you are getting lambda is equal to here 3 upon 2y. Okay, 2y. Okay, so by the help of this you are getting x square plus y square is equal to 136. Also you can write this like this: x is equal to minus 5 upon 2 lambda and y is equal to 3 upon 2 lambda. Now the both value you have to put here. It implies that x square plus y square is equal to 136. X is equal to this minus 5 upon 2 lambda whole square plus y square is equal to 3 upon 2 lambda whole square is equal to 136. Okay. So now 5 5 ja 25. Okay. 2 2 ja 4 lambda square. Okay. Then plus 3 3 ja 9 upon 2 2 ja 4 lambda square is equal to 136. So now solve it, or lambda you can place here. It's totally depend on you. So now you can write 25 plus 9. Okay, 25 plus 9 is equal to 136 into the 4 lambda is also here, so it will become here. Or you can multiply 4 lambda here, then you are getting 4 lambda square. Okay, so now 25 plus 9 is equal to 34. 34 is equal to 136 into 4 lambda square. Now you can cut, then you will get lambda square is equal to 34 upon 136 into 4. So now you can cut, and you are getting 2 to the 4. Okay, you are getting 1 upon 16. Okay, so now lambda is equal to plus minus 1 upon 4. Lambda is equal to plus minus 1 upon 4. It implies that x is equal to minus 5 upon 2 lambda. So it implies that you are getting, if you are putting lambda is equal to plus 1 upon 4 or minus 1 upon 4, so you are getting two value. X is equal to, number one is minus 10, second is 10. If you are putting y is equal to 3 upon 2 lambda, one is minus 1 upon 4, then plus 1 upon 4. Again you are getting two value, 6 and minus 6. Okay, so you have four value, minus 10, 10, 6, minus 6. Okay, so put different value, then you will get different output. Okay, so you have four value. First value is this minus 10, that's and 6. Okay, second value is minus 10 and minus 6. Third value is 10 and 6, and 4 is 10 and minus 6. So you have four value. Now you have to put this here. Okay, so in this condition you are getting four different value. Okay, so you have to put the all value here. So if you will put, then you will get 5x minus 3y. If you will get here, put here, then you are getting 5 into minus 10 and 3 into 6. Then this time you are getting minus 68. Okay, calculate it. Now you put minus 10 and minus 6 here. In this condition, 5 into minus 10, 3 into minus 6. This will be plus. Then after then in this condition, minus 10 and minus 6, then you are getting minus 32. Okay, so again you have to put this 10 and 6 here, 5 into 10 and 3 into 6, 50 minus 18. 50 minus 18 is equal to 32. Okay, again you have to put this value here, 5 into last value I am just calculating here, 5 into 10. Okay, minus 3 into minus 6. Now you can see that 5 into 10, 50, minus plus 6 3 is 18. This is 68. So you are getting 68. So you are getting four value, first, second, third, fourth. Okay, so which one is the greatest value, which one is the least value? You can see that is the minimum value and that is the maximum value. Okay, he will ask at what point it has maximum value and at what point it has minimum value. At this point, minus 10 and 6, it has minimum value. At this point, it has maximum value. That is the answer. I think that you understand. Okay, in the exam they will change the question. but the method is same. You have to apply this method. You can solve any question. I think that you understand. Thank you so much.